Friends, today we are going to see the measurement of the leaf water potential. So, water potential is nothing but the water potential quantifies the tendency of water to move from one area to another due to the osmosis, gravity, mechanical pressure or matrix effects such as capillary water or the capillary action which is caused by the surface tension. And for measurement of the leaf water potential, we are using the pressure chamber. Pressure chamber is nothing but the small gadget, and this gadget is used for the reference measures of crop water status, that is a leaf water potential, and leaf water potential is measured in bar or psi, and that is nothing but the 1 bar is equal to 15 psi, and this is the different parts of the gadget we are going to see here. This is the cylinder. This is nothing but the natural gas cylinder. Nitrogen gas is filled in this, and this is we have to see this is a knob, or this is a hole to exert or to supply the gas from this pipe to this chamber, and this is the hook or the hole to off or on to supply the gas for this chamber. And by doing the on of this gas, the gas will be moved from this cylinder to this chamber. And this is another hole, that is when we are supplying the gas, which is showing in this pressure gauge, the psi and bar, as likely I told you previously. 1 bar is nothing but is equal to approximately 15 bar. And after that we are installing the inserting the leaf in this chamber. Chamber is the instrument, or this is the small gadget which estimates the capacity of the cell, to retain water by pressuring a leaf with a natural gas. Means this is the instrument using to measure the water retained by the cell of the plant or leaf by pressuring the natural gas in this chamber. This is the broccoli crop. We are going to work out the leaf water potential of the broccoli crop, and here is the petiole of this leaf is very big, and hence we have to collect the sample from the midrib, which is going to easy to work out the sample, and hence we are going to take not from the petiole, because this petiole is very big and it is difficult to insert in the pressure chamber. Hence we have required the leaf from the midrib. So we are going to take now sample for the leaf water potential in this way. So you take the regular polythene bag, insert the leaf in this, and you should cut it from the midrib by the blade, and the sample lift back to the pressure chamber. Its time is 30 seconds to the 60 seconds, not more than this may be taken for the sampling. We have now going to start the sampling of the leaf water potential of this. First you start this valve supplying this gas to the this chamber. Now we have start this by rotating this. You have seen this. We are going to rotate on the supply of the pressure, that is natural gas, to the cylinder, from to the chamber. So after that we have to remove this lid. Removing this lid by small applying the pressure, you uplift this lid and you should keep in this way. Then you take the leaf sample, remove it, you take the cut. This is a mid rib because the petiole size is very big. We are taking this mid rib. This should insert in this rubber packing so that will not leak the gas. Oh, it's again big size. You have to reduce the. So insert like this. Again, you should get in this way, then you like the rubber clip, then again insert the bronze clip in this way. So it's insert in the chamber immediately by passing the time, while it's again required the plain cut. Take care during cutting, it should be the sharp, and after that you should be tied this lid by this hole in this way. You should press and tight this first this lid. After that you again tighten this. The gas should not be leaked from the chamber. And after that you take a sharp cut by the blade, which will be plain. Okay. So after that you should start this hole to supply the pressure of the gas in this chamber. So this is again the hole. We have now start the gas from this cylinder to the chamber, and you have seen here on the pressure gauge that will going to increase. So you release the slowly gas. If it is going to increase the pressure, then it will create the problem and we are not getting the reading. So that's why we have to slowly increase the pressure. And after that you observe here after some extent limit or the time applying the pressure, you are getting the oozing the water from the xylem of the petiole. Here we are use the mid rib of the leaf. Okay, so you have see to so if it is not tight, then gas will get leak, and the leaf water potential or the amount of the tension depends on the soil moisture, resistance of the. It is depend on the soil moisture, resistance of to move from root surface to the water conducting vessel, that is xylem, resistance to flow through the xylem up to the plant, resistance from xylem to the leaf cells, resistance to water losses from the stomatas depending on the degree of opening. Means soil moisture, it is depend soil moisture, resistance from the soil to the stem, resistance from stem to the stem xylem to the cells of the leaf and resistance to water loss from the stomatoes into the atmosphere, and according to that we get the leaf water potential. So we have now see the pressure is up to the 10 bar. If the no stress in the plant, then reading is coming. You see now oozing is there. Okay, so the pressure at this, you see the pressure at this oozing the water from the xylem of the midleaf of the broccoli leaf, and you see here near about 154 to 154 psi or the 14 millibar 14 bar pressure is required for to exert the or remove the water from the broccoli leaf, and this is the leaf water potential. So if the mild trace is there, so mild trace is there, if mild trace is there, then the leaf water potential is 7 to 8 bar, and if there is more trace is there, then it is coming up to 10 to 12 bar, and if trace is again more, then it is more than the 12 to 14 bar the reading you have getting. In this way you have seen the pressure on the pressure gauge, and here we have seen the water is coming out or oozing out from the petioles clearly. Might be if you applying again the pressure, then what happening, sometimes petiole will be cut, more pressure is exerted, then it will be the cut. Okay, so in this way we have completed the whole process about the measurement of leaf water potential of a broccoli crop at a mid time or midday, and the midday we have to take the observations at 11:30 to 13 hours at the solar noon time, and then you will getting the correct reading. So thank you.